Hello, welcome to Biology 1. The raw is equal to the rounded atomic weight. Okay, so we want to use the raw for hydrogen. So if we round this to the nearest whole number, then that number will be 1. So now I need you to take your time and I need you to calculate the number of neutrons for hydrogen. How many neutrons does hydrogen have? All right, so what did you come up with? All right, so if remember, we're using the raw, and so if we calculate the number of neutrons, we know that mass, again, is equal to, you said, is equal to protons plus neutrons. So then you know that my number of neutrons is going to be equal to 0 for hydrogen. So just as a recap, how did we get that? We said 1 minus, because remember we're using the rounded atomic weight, which means that we're rounding to the nearest whole number. 1 minus 1 is equal to 0. Okay, so let's do one more. So if we have sodium, we know that using the raw, what is the raw for sodium? You're absolutely correct. It's going to be 23. So 23 is equal to the number of protons, which comes from the atomic number, plus the number of neutrons. So if we subtract 11 from both sides, that's going to give us neutrons is equal to 12. Very good. All right, let's keep going. So what if I told you that atoms have a 0 net charge overall? If atoms have a 0 net charge overall, that means that if we take two things, that would produce that. If you're thinking about, these protons, the neutrons and electrons, there are two of them out of the three that will help us reach that value of 0. So what we're saying is, if the proton number balances the electron number, then we know that that number will be 0. We get those charges balanced. Okay, so for example, if we were looking at hydrogen, remember, was 1 and 1.00, maybe one more 0, or maybe just 9, 1.009. We said that this guy, hydrogen, has 1 proton. We know protons are positive. He has 0 neutrons, and plus, remember, neutrons have a neutral charge, so it can't be the neutron. But the electron is balancing the proton. So that means we also have what? 1 electron, and that's going to give us that overall charge, negative, 1 positive charge, 1 negative charge is going to give us what? A 0 net charge overall. Alrighty. So atoms may also lose or gain their electrons and become charged atoms that we call ions. So there's two different types of ions that we need to discuss, and those are cation as well as anions. So let's discuss a cation. Cations, they may lose or gain an electron, or we could lose more than one, so electrons. And when they do, it says, and they will become positively charged. Okay? So then, therefore, an anion may gain an electron or electrons and become negatively charged. So let's just propose something here. What if we were looking at sodium, for example, and we know, if you remember, sodium has 11 protons, and we know that those are positively charged. And what if it's in the area where someone has a stronger draw on the electron, so something maybe like chlorine, and he had 11 electrons, then we know at that state he's neutral. But he may be in the presence of someone who needs that lone electron that's in the outer shell, and we go from 11 protons and he loses one, and now he's happy because he has 10 of them. So we now have what? If we're looking at a cation, positive 10 negatives, 11 positive, 10 negatives leaves us with a plus 1. So this would be a cation because there's more positive charges than there are negative charges. All right, we'll revisit that again later, but that's something to start thinking about. All right, so let's look at how biologists get a mental image of an atom. Well, they use what is called the Bohr model in order to get this mental image of the arrangement of those subatomic particles, the protons, the neutrons, and the electrons. Early on, we learned where each of those guys was located, so it shouldn't be that hard for us to figure out how to draw this structure. Niels Bohr is responsible for this structure that is currently used by biologists. So the question is, what do we need to know? What do we need to know about each atom in order to draw a Bohr model for each of them? Well, there's some rules that we need to apply and abide by, okay? And that is that in the first shell, that first shell can only hold 2 electrons. Any shell following that first shell can hold up to 8. Now, we just need to remember that. The shell cannot, for example, this shell can only hold 2, which means we can't put 3 in it, we can't put 4 in it, it only holds 2. Any shell following that, we said 8. It doesn't mean we can put 9 in it or 10. It says it can only hold 8. So if it has 8, we say that it is following the octet rule. So now we need to do some calculations. For example, if we were to look at hydrogen, let's pull up the stats of hydrogen. Hydrogen, if you remember, had an atomic number of 1. It had an atomic mass that was equal to 1.009, but we use the raw, so we're just going to call it 1. And then it also, because we know the atomic number, we can say that the number of protons is equal to 1, because we know that these atoms are typically have a 0 net charge overall. We can go ahead and say that the number of electrons is also, at this point, 1. And then we now need to calculate the number of neutrons. And if you remember earlier we said mass is equal to protons plus neutrons. So mass is 1. If we subtract 1, we know the number of neutrons is going to be 0 for this guy. So we know that if we were following the rules, we're going to put what? 1 proton. I'm going to draw a nucleus and put that 1 proton in it. There's no need in putting any neutrons in it because we don't have any. How many shells do you think this guy's going to have? You're absolutely correct. It's going to have 1 shell. And how many electrons can go in that 1 shell? 1. We only have 1 electron. And we're going to put that 1 electron in that first shell. Okay? So, we have achieved the drawing of the Bohr model for hydrogen. Okay? Let's move on to the next one. How about helium? Okay? Helium, let's do the stats on helium. Helium, if you're looking in your periodic chart, because that's where you're going to get this information. So, helium has a mass of 4.0028 or 6. My eyesight is not so good. And then he has an atomic number of 2. So let's get the stats. The atomic number. Oh, there it is. The atomic number is equal to 2. The mass is equal to 4 because we use the raw. The number of protons, because we get that from the atomic number, is equal to 2. Because we know that it's electrically neutral, the electrons the number of electrons is also equal to 2. The number of neutrons happens to also be equal to 2, because 4 minus 2 is going to be 2. Alright, so what should this guy look like? And we'll check ourselves on probably the next slide. So if we were to draw this, how many protons are we going to put, and where are we going to put them? So it says we're going to put 2 protons in the nucleus, but we're also going to put 2 neutrons in the nucleus. So here's our nucleus. And then it says we're probably only going to have 1 shell since we have 2 electrons. So 2 electrons. So we know that this shell is complete because it can only hold 2. Let's see. So there we go. Now, for our purposes, remember, we're going to just write 2 protons, 2 neutrons, because we can end up with a ton of these guys. Alright, and let's try one more. Lithium, the stats for lithium. Protons, let's go with atomic number. It's equal to 3. Number of protons, 3 electrons. It's equal to 3. Atomic mass is equal to what is the number? What number? Correct if you said 7. So then the number of neutrons is equal to, what is the number? 7 minus 3 is equal to 4. Alright, so how many shells are we going to have? 1 or 2? 3 or 4? Alright, if we look at this, it says we're going to have 3 protons in the nucleus, but we also have neutrons. We're going to put 4 neutrons in the nucleus. The first shell can only hold 2. That means we're going to have 2 shells, and this last shell will have 1 in it. Alright, so that is the Bohr model for lithium. Alright, and here's the cartoon drawing, okay? Alright, so we will stop. No, let's go ahead and do this. Why just the first 20? The reason being is because we know that if we're looking at, so for the test, you're going to have to know the first 20. And if you're looking at your periodic chart, you'll see that the first 20 are basically common atoms. And we know that living things are made of simple common atoms. So that's why we want to look at and study and make sure we know the first 20 for the test. And for the test, the only thing that you're going to need to know are the symbol and the element. You'll have a chart. You just need to be able to, the name of it. You need to know the name and the symbol to be able to draw things off the chart. All right, so it says, now, 95 to 98% of our body is composed of those 6 common atoms that we refer to as CHNOPs. Okay, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. All right, that concludes our lesson on chemistry for today. We will pick up and move further into this discussion with our next video. I hope that you have a wonderful day. See you next time.